know. Enjoy the music.
That's right.
Now, imagine me at 16 years old in a Datsun, not a Nissan, 280Z, beautiful mustard yellow, deep, deep coat, with hair longer than you could possibly imagine, cruising down the street with my favorite girlfriend that week, cranking that song. That was me as a teenager, and now I'm paying the penance because all my hair fell out. But I still love the music. Hello, everybody. My name is Jay Egg. I'm with Egg Geo. I'm so grateful to the McCotter Energy Group for producing this video. Stand up and take a bow, guys. Come on, I want them all up there. Come on, McCotter Energy. They're one of our clients, and they are focused on geothermal, and I am so proud to be able to represent them. Dan created that video at probably in spring this year. We had a 2-day webinar over there, packed to the gills with presenters, and it was a blast. Greg Cunniff and I got to go over and present for Egg Geo, and we had a lot of fun. And we love our partners, and we have a lot of partners in the geothermal industry. I also want to thank IAPMO, John. Who knows John Mullen? Let's give him a round of applause. He is an amazing guy. He is, if you ever look online, if you're on LinkedIn, you've got to check this guy out. I don't know how he does everything he does, but he does, and he does it well. So, John, thank you so much for putting this together. These things are so well organized. I just couldn't be happier to be here. Greg presented yesterday on building energy system efficiency tool, and it just won the AHR software award for this year. So we are just, having a great time. Invest helps model geothermal systems. So if you don't know about it, look up the Building Energy Systems tool, and you will be amazed. It'll cut your time for modeling systems to 1/10. Still have to do the modeling later if you want to design it, but that's okay. All right, so I have a lot to cover today, and let me see if I can get this right. So I'm going to start. This is about geothermal energy networks and what a revolution they've become in the industry. The number one thing that I like about geothermal energy networks is it creates jobs. It creates good jobs for tradesmen, for electricians, plumbers, HVAC, excavators, you name it. It creates a lot of jobs, and we're going to talk about several things that it does as we go through this. A lot of times you don't think about it when an energy network goes in or a geothermal system goes in, but as you can see in this image, what it consists of, and we're going to go right to the beginning, so I'm starting at the end and we're going to go right to the beginning in just a little bit. What it consists of is basically a condenser water loop, an ambient temperature condenser water loop that runs around a city, and you can see that's that opaque line there that just runs around, and it's moving BTUs in water. And it's moving around, so when your buildings like your data centers are rejecting heat, your buildings that are apartment buildings can absorb heat, and any imbalance is fixed by surface water exchange, combined heat and power plants, energy piles, water features, wastewater. It can have all the components that a good building would have, but it's city-based. And what it does is it tremendously increases the efficiency of our cities, and it decarbonizes them very, very quickly and easily. A little bit about what we do. We're very involved in education, code development, legislation. We're consultants for the industry. Everything we touch has to have a geothermal component. We don't do anything else. And we are friends to everybody everywhere we go. We are not there to take anybody's job. We are there to make a geothermal project go through. If there is somebody with our suite of skills, we won't come in town. We simply will not do it. We do not take work from people. We only go where we're wanted, and we do the work that nobody else is quite able to do yet. And that's our model. I put a couple of our textbooks up here and some flyers about our company if you want to learn more. You won't see us in many headlines as a designer of a system, because by the time the design gets done, we've already handed it off to an MEP firm, a manufacturer's rep or something like that, because we want to train up MEP firms to do what we do. There is nothing in our business that's proprietary or special. We don't sell anything but our time, our educational assets, and our help to validate, and we change codes. We work with, I serve on the IAPMO Uniform Mechanical Code Committee, as well as the Thermal Energy Networks Task Force, which is right now writing the code for 2027 for thermal energy networks. In addition to that, we also are the writers of the new Pipe Fitters Union Thermal Energy Networks Manual, which will be out in about 2 years, and we design their training trailers. So a little bit about us. It kind of started, we were consultants in New York from about 2013 on, and during a tour while we were doing training for the state, somebody told me about the Empire State Plaza, and that's the capital of New York. And they told us that they were putting in a CHP plant. They were right now on shore power. In other words, they were using power from the grid, but they wanted to go off the grid. So the local activists were complaining because they were going to be burning more natural gas. And I said, I don't know. I don't know if I even want to get involved. It sounds very petty. And I looked into it and I realized, no, it wasn't. They were going the wrong way. And that's where we usually disrupt things. And so we did disrupt things on this plaza. They had a $100 million CHP plant ready to go in. And we said, you guys are crazy. You have a river, and this doesn't show the river, but you have a river where you're already exchanging energy for cooling towers. And so we gave them, we wrote up some articles on it, and basically the state listened and they stopped a $100 million project for CHPs and switched it over to geothermal. And that's when it really started getting traction. After that, we won the Constellation Prize for Policy Change because of that little stunt, which really upset a lot of people, by the way. They tried to run me out of town. The governor's office tried to run me out of town, but now we're their friends. And then we made friends with the Pipe Fitters Union, because the first thing they noticed was, what is going on? We're losing our jobs because they're decarbonizing, but it looks to me like we're going to be putting in a lot more pipes in the ground and in buildings. We might not be piping natural gas, but we're going to be piping water. And so this guy right here in the middle, he's the business manager for the New York pipe trades, New York State pipe trades. He called me up and he said, Jay, what do you got going on? This could be big. And I said, let me show you, John. And I took him around New York to some of our projects. And this is one of the tours we did. He was blown away. And I'll tell you a little bit more about that story in a couple of slides. In the meantime, at the same time, in Massachusetts, they had a group called Mothers Out Front that was just mad as wet hens that gas was leaking through the ground all over their city. And they had the PUC had just given $9 billion to Eversource Energy and said, yeah, go fix your leaky gas pipelines. And Mothers Out Front said, not so. No, we're decarbonizing. And so what happened was they did a study. They got together with HEAT, the Home Energy Efficiency Team, which is now a monstrous DOE.org, meaning it gets most of its money from the DOE, and they changed the face of Massachusetts. I was just up there last Saturday at this time touring the nation's first retrofit thermal energy network in operation, 6 blocks, 270 buildings on it, put in by the gas company. So when you walk the streets, instead of gas valves, those little round covers you see, it says geothermal. And then they put heat pumps in every one of the places. They did give people a choice. Listen, what kind of answer would you give to this? Listen, you have a 20-year-old furnace. We're going to put in a brand new geothermal heat pump. How much? Nothing. Just let us put it in. It worked, and it's in. It took less than a year for the entire system to go in, and they're expanding it now. This is what's happening in New York. It's called the Utility Thermal Energy Networks and Jobs Act. It passed law because of the pipe fitters unions, which have such a heavy vote in New York and throughout the country. There are 400,000 families. They're behind it. They're like, this is business, and so they got behind it. They submitted the new bill with the local activist groups, the union did, in January of 2022. It was signed into law on July 5th, 2022. I was there with Governor Hochul when she signed it. It was amazing. Now 15 states either have passed or have legislation like this. And the legislation doesn't just say, yeah, you can do this. It says, no, thou shalt do this if you're an investor-owned utility. It's got teeth in it. It's like, stop being lazy, learn this, and put them in. And that's what they're doing. So we do a lot of work for the UA. This is the Chicago thing where they first had us introduce the concept and the training, where they were basically kicking off what we're doing now. This guy, Senator Hansen, got all the laws passed in Colorado. Now, Colorado is one of the biggest uptakers of geothermal. He just took a job. Do you know how much a senator makes in Colorado? $48,000 a year. He just got hired as the CEO of La Plata Electric Association. Any guess what he makes there? $400,000 a year. And he's helping them go geothermal. He's my new best friend. All right.
He's catching up with you.
Yeah, exactly. So this is a little bit about what we do. These are some educational assets. This is some of the training we do. This is a training series we created for the State University of New York during COVID. This is another one of our tours, taking the Union Brethren through an energy plant that was getting ready to be converted at Penn South in New York City. This is how high-end the UA is. I was in Ann Arbor the end of last year, and this is Rob Vilches. He's my boss at the UA. He signs my checks. And that's him and Secretary of Energy Granholm. They're bosom buddies. They are best friends. Now, not anymore. We have a new administration. But guess what? Who knows who the new Energy Secretary is? Anybody know the name? Chris Wright. Chris Wright is from Colorado. Chris Wright had to divulge during Senate hearings his assets. Most of his assets are in a little company in Texas called Fervo Energy, the biggest geothermal company in the United States. If you haven't seen the headlines, geothermal has been spared by the new administration as the only feasible asset, and they don't call it renewable because they don't care about that. They call it drilling, 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 baby. All right, so this is Secretary Granholm and the General Secretary of the UA. These are the training trailers we designed. They're really cool because the new ones are going to be super cool, and they're going to have a lot of what people like McOtter distribute, like shark and all kinds of wastewater, cool stuff, you know, good pumps and everything. So what we do is we now circulate informational materials. We help states with that. And we do, you know, we're cited in articles all the time. And this article, Standard & Poor's Global Market Intelligence, interviewed us and many other people much smarter and said, what is going on with these? We're seeing these go in. And basically the report came out here. And when you get this slideshow, you can click this link, which is live yourself. It says that thermal energy networks are the last great frontier of energy distribution. It is what's next. By the way, I don't have time, you know, like most of us, I'm doing 8 hours in 1 hour. And so let me just tell you that in the 1950s and 1960s, the United States had an energy revolution. That energy revolution was natural gas. During that time, the 50s and 60s, 2.5 million miles of pipe went into our city streets, retrofit, connected to 65 million buildings. That's what we're facing between now and 2050, but with thermal energy networks. That's how big this is. And I was just in Boston last week, and one of the drillers, there's some big, you know, driller reps and union reps. They said, yeah, we were listening in 2022 saying, we're not going to have enough drillers. We're not going to have enough drillers. And we just kept sitting around going, when? Well, it was all in design at that time. Now they can't even, they're buried, they said. And working in areas like the upper Midwest, we can't even get drillers to bid multi-million-dollar projects anymore. Thankfully, there are some new drilling technologies and companies, big companies like SLB, Schlumberger, which are coming into town, and we're inviting them into the upper Midwest to start handling some of the load that's coming on. But it's starting to catch, and I wish I could invite Dan and Mary Kate up here to talk about they spend a lot of money trying to get it to catch, and that's appreciated. A lot of people are doing that. But it's starting to catch. So, yes, Governor Hochul signing the bill. This is where we go back to 2+2. Because I don't, even though we're at an HVAC conference, I don't expect everybody here to know the basics of HVAC, so I'm just going to do a couple of things on that. John, what time did we start today? I tend to lose track of time. I got 45 minutes, right?
30, yeah, you're good.
I got 30 minutes left?
No, 2:30, you're over.
Oh, 2:30, good. I have 45. I can stay at this pace then. All right. So in an HVAC system, you can either have, if you're talking heat pumps, you can either have an air source heat pump or a geothermal heat pump. The equipment is exactly the same fundamentally. The difference is the condenser, in other words, the compressor out here, is put into the bottom of this all-indoor unit. And instead of having a condenser outside that absorbs heat from the outside air in the winter and rejects heat to the outside air in the summer, you have pipes underground. And the reason the pipes are underground is simply because the ground stays at the same temperature all year. And that, you know, if you just gave an average of the United States, it would be 55 degrees year-round. So when it's freezing outside, it's a much better heat source. And when it's 90 outside, it's a much better heat sink. Because of that, they operate efficiently all year round, far more efficiently than an air source heat pump. And in addition to that, they last a lot longer because they're all indoors. So there's a lot of positives, and that's just a couple of them. This is what they look like in an installed situation. Just to stay showing you two carrier units. This is a carrier air source heat pump. That's what it looks like. There's a carrier geothermal heat pump. That's what it looks like. And so you can see you're just missing the outside unit. Really, you're replacing the fan coils with a loop exchanger. And this loop is usually filled with fluid, water, sometimes with antifreeze, depending on how low the temperatures are. This is what you usually look at to go into a geothermal system. The initial pain is painful. I mean, it's treacherously invasive to tear up your backyard and put in 2 or 3 boreholes. And you used to be all the rigs look like this. Now they've got pretty slick little rigs. I think I may even have a couple of pictures of them that are a little less invasive, but still the trenching has to go on. But when you're done, that's that same backyard. That's all you have to worry about ever. And that is your energy source and energy sink forever. It's permanent infrastructure. It's HDPE. It's in the ground for 300 years or more. I don't have any way to guarantee that, except that the pipe manufacturers say HDPE is a forever pipe. It's not going away. So it's a beautiful thing once it's in, and it's quiet because you don't have anything outside. These all operate on the same Carnot refrigeration principle that a refrigerator operates on, where a refrigerator has a compressor, an evaporator, a condenser, and an expansion valve or a cap tube, and it just takes the heat out. It increases its potency or compresses it so that it's warmer and kicks it out the bottom. That's why the refrigerator feels warm on your feet at night. Same thing with an air conditioner. It's taking heat out, kicking the temperature up a little bit by compression and sending it out through the coils. So that's what a heat pump does. The only thing is that in the wintertime it reverses. So if your refrigerator was a heat pump, it would be a hot box as well as a cold box, and that's what a heat pump does. It can heat the inside and it can cool the inside. This, in longer presentations, I would actually go through this animated heat pump cycle, but anybody can do that on your own time. It's the best one I ever found on heat pump cycles and how they work. This is kind of cool because it just shows all the versatility of a heat pump. You can use a geothermal loop, a combined or common geothermal loop to do radiators, to do radiant in-floor, to do domestic hot water, to do water to air, to do a pool heat pump. You name it, you can do it. As a matter of fact, heat pumps are getting so powerful. I know McCotter distributes a line of heat pumps that'll do 250 degrees steam, one lift. There are heat pumps coming out of the woodwork, we're going to be hearing about them very soon, that create hot enough fluid to to run deep fat fryers and to do grills for cooking hamburgers and what have you. You'll be able to use heat pumps to cook. I remember the first time I heard somebody say there's heat pumps to dry clothes. I thought that was pretty amazing. But heat pump technology is really getting there fast because there's a need for it. So these are the distribution systems I just talked about. A little bit on the way we measure energy. It's pretty simple, really. We measure energy in BTUs, and 1 BTU, or 1 watt of electricity, is the equivalent of 3.4 BTUs. A BTU is about the energy that a wooden matchstick creates when it's burned from top to bottom. BTU, coincidentally, is the same amount of energy it takes to raise the temperature of 16 ounces of water 1 degree. So, if you apply 1 watt of energy to this bottle of water and it's 72 degrees right now, it will be 75.4 degrees once it's got a watt of energy applied. That's how energy works, and that kind of gives you an idea of what everything is based upon. So in the air conditioning and heating industry, we rate things in both energy efficiency rating and COP, but COP is the simplest to understand and it's universal worldwide. COP is the coefficient of performance, and it simply means it's the energy delivered, how many BTUs are you giving me, versus the energy supplied, how many BTUs am I using? So, if you're using an electric heater uses 1 kilowatt of energy and delivers how much? Think of the conversion on the last slide, 3.412 BTUs per watt. That's 3,412 BTUs of heat. Real simple. I think it's very funny sometimes when people say they've come up with the world's most efficient electric heater. That's electric resistance heater. That's because they're all exactly the same efficiency. It's all getting into the space. When you put a kilowatt in, you're going to get 340. It doesn't matter whether it's through fan heat. It's going to deliver the same amount of heat to the room. There is no... Now, the magic happens when you deliver 1 kilowatt of energy to a heat pump, because a heat pump doesn't burn the kilowatts, burn the electricity. It uses those kilowatts to drive a compressor, some fan motors, and some pumps. And for that 1 kilowatt of energy, a geothermal heat pump will pump 4 more units of energy out of the ground and give you a grand total of 5 units of energy in the space, for a grand total of 17,060 BTUs of heat. We constantly get accused of sorcery when we talk about 500% efficiency. They say, every other day we'll have a comment on a social media post. It's impossible to get more energy out than you put in. Well, what are they missing when they say that? We're not getting more energy out. We're pumping energy from one place to another. That's what we're doing. We're using energy in a smart way. And these heat pumps, every manufacturer, I promise you, every manufacturer of heating and cooling equipment has a geothermal heat pump line, or at least a water source heat pump line, which is the same thing. The difference is in the ARI ratings, a geothermal heat pump is what's literally an extended range heat pump. It means they are rated at least to 25 degrees Fahrenheit and up to 110 degrees Fahrenheit, so that you know they can handle the seasonal swings, which is for another conversation. But these heat pumps, they come in garden variety, residential, Marriott style, stackable units, between the floors, above the ceiling, P-tax, commercial, and they come in vertical water to air, horizontal water to air, modular, stackable, pool, or dedicated GHPs, which are water to water. You're using water source and you're delivering water. This is a dedicated domestic hot water heat pump. That's a dedicated pool heat pump right there. You can do pop on the top of the building, rooftop package units. You can do 100% fresh air units, whatever you like. And here's the benefit. When you look at this picture, no more outdoor equipment to replace. More hurricane and storm resilient. HVAC system longevity goes up by a factor of 3 because it's not outside. You eliminate your combustion boilers and cooling towers, which I'm going to cover a little more. That's an amazing thing right there. Cooling towers are the #2 consumer of water in the United States in the built environment. Most people don't know that because they say, yeah, why are you telling me that? We need them, if you even know what one is. And then noticeably superior comfort in both heating and cooling modes, and that's because of the even heat source and heat sink. So the equipment operates more within its happy bandwidth. They have remarkable system efficiency at standard equipment pricing. Just like I told you here, where is my thing? I wanted to go to this one real quick. I'm sorry to go back so far. This heat pump is the same tech as this heat pump, and once the markets mature with a manufacturer, both heat pumps cost the same. The only reason one costs more is because the market hasn't matured with that particular manufacturer. So, here is a thermal energy network diagram. Just the logic. Both of them, I'm talking about comparing it to natural gas. Both a natural gas system and a thermal energy network system have a pipe in the ground. The same infrastructure. One uses a heat pump, the other uses a furnace or a boiler. One delivers heating and cooling, the other delivers heating only. The source input for a geothermal heat pump is local and free. It's the earth underneath you. The source input for a natural gas pipeline is interstate and it's not free. So, I mean, I don't even have to do a survey of which one probably works best because they're both excellent infrastructure. It's just one is for our century. So Ronald Reagan used to be a spokesman, by the way, for all-electric homes back in the 50s before the natural gas pipelines went in. Did you know that? How about that? And you used to be able to get these medallions if you had an all-electric home. I'm hoping sometime in the future the U.S. government will have an Energy Star rating kind of thing like this for all-electric homes. I just said sometime in the future because I don't see it happening anytime soon. At any rate, this is why the Fed spends so much and states spend so much on geothermal heat pump subsidies. Why do we need a subsidy? Who can afford $20,000 to $40,000 to drill what amounts to a water well in your yard? Yeah, some people can. The people that really need it can't, though. So that's what the subsidy is needed for. The equipment costs and installations, it's still tied to ductwork or it's a hydronic radiant system. But here's the trick. This is what they recognized back as early as 2010, if not before. When they put the first floor air source in the ASHRAE headquarters in Atlanta and the second floor GHP corrected for BTUs and kilowatts per square foot, this is what they saw. The geothermal heat pumps peak in the summer, and in the winter, they do the job of heating without even hitting the summer peak. The air source heat pumps actually don't peak in the summer. They peak dramatically in the winter. And why do you think that is? It's really hard to get heat out of sub-zero or sub-freezing air. No matter how good the heat pump is, every degree cooler you get, the more it's going to work. And so that is why, and they said, and this is the problem that's facing the nation and the world right now, how are we going to handle the electric load for all this new electric stuff? We say in the HVAC industry that we're not the problem. If you could air condition before, you can handle the same job in heating. And the Fed and everybody that needed to listened to it, and they said, you know what, if we put our money into subsidizing geothermal heat pumps, we might save a lot on electrical infrastructure. This is another example, the tale of two buildings, two office buildings identical, installed or built in Oklahoma, one with air source heat pumps, one with geothermal heat pumps. National Grid did a study on it and said, look at what would happen to our earnings curve if we went all electric. We would shave our peak in the summer and we would add electrical sales in the winter. Everything seemed to be working out. And then in Ontario, Dunsky did a study for the Heating, Refrigeration, and Air Conditioning Institute of Canada, and they said, let's just say everybody in Ontario, which is a population of about 7 million, had to turn off their natural gas all at once. And we had to give them a choice of heat pumps. What would that do to us? And we said, well, not we said, they said, and I'm telling you now, first of all, they'd have $1.1 trillion in natural gas expenditures that would go away. So that's the no-brainer either way. Whether you're with an air source heat pump or a geothermal heat pump, it starts to make a difference. Because with the geothermal heat pump, they're going to spend $137 billion more to outfit those homes with geothermal. With the electricity savings, well, it all comes back because they save electricity. But here's the ringer. The electrical infrastructure buildup they would save is $500 billion. So everything's better with geothermal, and they don't have to build out the electrical infrastructure as much. So it proved it out there. In addition to that, I don't know about you, but air source heat pumps can get real darn ugly real quick. I mean, I know. Yeah, call me on it. Third world countries, the mini splits, I know.
That's not New York.
Some of those, I have some of New York that would curl your toenails. I just want to know who the guy is that's going to climb this ladder and change that fan motor. Okay, enough on that. Oh, here's my best friend. That's what's... By the way, yeah, you can buy these online and in Home Depot and stuff, and then you'll end up like this guy. And so that's what's happening. HVAC systems they're called appliance grade units. They're being installed as really easy. You got no problems. And then they end up like that. So that's why I'm involved. We are involved in code committee hearings. The CSA ANSI C448 is just about to come out with their new version. This is the very first geothermal code. I was on this committee in 2015, and then they inducted me and a bunch of other great folks into the Uniform Mechanical Code, and we are rocking it. In 2021, we got our first geothermal chapters. They got a lot better in 2024, and in 2027, we're going to have thermal energy networks in there. It's awesome. Those are our books again. We do a lot of kids stuff. These downloads are free on our website, on our Kids Corner. And we were at MIT last week, and they're commissioning us to do K through 12 stuff too. So I say to people, they say, when will you know you've made it? I said, when I can go to Chick-fil-A with my grandkids and get a toy that's geothermal themed. We really need this, you know, and I don't know when that'll be. But I think kids, that's where we get it going, and I think we're really close to doing that. There's a lot of fun things we do along those lines. This is our SUNY education. Let's talk about large-scale stuff and where we're going. This is, in 2023, we were commissioned by Rochester, Minnesota, where Mayo headquarters are, to come up and train several of their governmental bodies on what's next for geothermal. So we went up there, and they were already drilling wells for some downhole exchangers, which we'll talk briefly about. And so we had a lot to look at, and we were so impressed, we had the very first Thermal Energy Network Symposium in Rochester in 2024, in March. And the mayor was there, senators, and everything. It was a lot of fun. The last one, that's the reason I was in Boston, was at MIT. We actually had 4 conferences there because there were a bunch of different organizations all vying for the hot spot there, and I was at each one of those and had a little fun at each one of those. So city centers are growing, are adhering to this in droves. Of course, the UA is behind us, IATMO's behind us, many of the publishers. Put it this way, if you got something to write about geothermal, any publisher will publish it. They are so keen on geothermal right now. So we'll do a little bit of a case study thing and get into some really cool stuff after this. So this is a public school geothermal central plant that was converted, and what they basically did was took out the cooling towers and they put in these two geothermal exchangers right here, redundant exchangers, so one plate and frame exchanger can be cleaned while the other one's out of in service. And this is what a geothermal heat pump looks like in a medium to large commercial building. This is a good story here because this retrofit was in a church that we got called to in 2013 in downtown Tampa. And when we did the research on it, it had been on the same chiller since 1949. And when we started looking for the condensers or the cooling towers, we realized it didn't have one. And then we realized that it was a geothermal system. It was pumping well water through the tubes of the chiller and back down into the aquifer. And we said, well, this has got to be getting on its last legs, because they did want to stay with that solution. So we had a well expert come over, a hydrogeologist, and he said, no, good as the day it was put in. 63 years later. Now, how many cooling towers or condensers would you go through in that time? I can't even, 3 cycles, 4 cycles? Well, we took out the chiller and we put in heat pumps, and they're still, of course, running today. This one, particular one, had a 24-ton and a 12.5 ton. Such an easy replacement. This is one of our first really big projects. This is the public safety complex in Pinellas County, Florida, right by Clearwater and St. Pete. It's a 911 emergency operations center. The main reason they went with geothermal there is, what is the main emergency in Hurricane Central? It's getting your cooling towers. I mean, it's a hurricane, but the main weakness would be getting your cooling towers taken out. So they wanted everything from the outside. So they said, what would it take to get rid of these cooling towers? And they went with the geothermal solution. So this is a 1,500-ton plant. It does also the morgue, the health department, the police station. It's a campus. And this is an example of one of 4 supply wells coming out and into these 24-inch supply and returns here. And it's really this simple. I like to break it down with hydronics. If you have distributed heat pumps, and if you could see the writing here, you would see that this heat pump says typical of 64 or 84, one of those two. And so it's 84 distributed heat pumps. They were on a cooling tower. You just valve it off and put an exchanger like you saw on that one for the central plant, and you tie it into some type of geothermal configuration. The same with a central energy plant. You just valve it off. You don't even have to take the cooling tower out. Just valve it off and leave it for backup, for needs plus one, and then tie it in. Yeah, I'm oversimplifying it, but really, that's my job, to sell you on this. I want to oversimplify it, then you have to hire me to figure out how to do it. And it is really simple though. What we do is we try to train MEP firms, architectural firms, and everybody how to do this so we become obsolete and can move on to what's next and best, and there is a lot of what's next. This is Cornell. We worked with Cornell on this. They had basically central cooling plants for their campus. At one point, they said, this lake, Cayuga, is pretty deep. It's 40 degrees year-round at the bottom. What if, and they put in the energy exchange building right here, they pump lake water through exchangers, and then they get year-round passive cooling. No chillers needed. Kind of like they do in Minnesota. There are some aquifer-based systems there where the water comes out of the aquifer in the 40s. They don't need active cooling. How about that? You gotta use your head though, because if you go to Florida, it's 78 degrees in Miami coming out of the ground. Now, they have a CHP plant, so they wanted to get off that. So they just drilled some deep wells. They're getting 220 degrees out of it. They would like to make electricity too. And we're working with them on some, what we call binary generating facilities for that. And they will eventually turn off this CHP plant. This is completely different from a normal geothermal system. They're using two different sources and sinks and doing it completely different. There are so many different ways to do geothermal. That's why it's important to, you can either really have a good time making all the right mistakes, or you can have somebody that's already made the mistakes for you advise you on it. This is the Cornell campus in Roosevelt Island, built in 2016. They have a standard geothermal loop field out under this lawn. And they actually put in a cooling tower too, which has never needed to be turned on, and they have a backup boiler. And here we are walking through the multi-stack 600-ton equipment room with some folks doing the tour. So it's really this simple, folks. We find your geothermal source, whether it's aquifer-based, closed loop, surface water, wastewater. We pipe it through your city, to your buildings, or just to your single building, and you get a geothermal system. It's really that simple. What we're doing, and this picture is for all my 10-year-olds, because I do this to all walks of life. We take the steam, this is Chicago in January, probably at one of our AHR shows. I don't remember when I took it, but it was a few years ago. Chicago, there's the Sears Tower, and there's the steam. Why is there steam coming out when it's 0 degrees outside? Because urban settings are cooling dominant every time. And now with data centers, you don't even have any idea how cooling dominant we are. We got so much waste heat, and we're going to talk about that. So this heat from these cooling towers, they get turned off. The condenser water lines get turned into the thermal energy network, and we pipe it to heat pumps in buildings that actually need it. This is an example, an FYI. As I said, we started contracting we were consultants for New York as early as 2013. The original question they asked us is, okay, this is a really good idea. How are you going to do this to 900,000 buildings in one island without turning it into Swiss cheese? And we said, you really want to know? Do you really want to know? Then fly us up there and we'll show you. And we did. And we showed them how you do it. And it's by moving energy from what we just talked about, buildings that have heat to buildings that don't. Case in point, we got this project in 2018 handed to us. They said, Geo, we have 15 22-story buildings in the middle of town. They have a 5 megawatt thermal energy load for heating in the middle of the winter. How many boreholes is it going to take to do that? And how many people to screw in a light bulb? And so we said, we did a lot of work, and we said, we literally put our feet on the ground and went door to door. It took us months to get the final solution, but we found the U.S. Postal Service, which, by the way, getting the data from that building took us 9 months. Everything is so secure after 9/11, you can't get anything, but we got it. Need to know. They have 8 megawatts of thermal rejection year-round because they have their own data center, their own equipment, and a lot of people working in there. So that 8 megawatt heat rejection load, we said, what if we pipe this in to that mechanical room and put in a 5 megawatt geothermal heat pump and didn't drill a single hole? And you're decarbonized. And they said, where do we sign? And we said, all right, and we're still working on it. The thing about it is, the reason we're still working on it, whenever they fund a project, it's a project to create breadcrumbs for everybody else. So everything we do, they basically require us to do a how-to manual and answer all the questions. This manual on what we're doing, it's us and many, many other great MEP firms are doing it, is hundreds of projects long and countless pages of data long, but it's really getting there. So not only did we tie in, are we engineered to tie in the U.S. Postal Service, but also a public school, a state university school, and now Penn South, Penn Station, and the subway are all tying into it. So it's turned into a really nice project. This is a really amazing project that has given us more data than anything else in the country. A good friend of mine, Carrie Smith, has started designing this in 2006, and basically they've got all these buildings on a central loop now, and it runs so amazingly because they just keep adding things to it and they keep sharing energy. And what was, 6,000 tons is now a 1,500 ton load. So this is what it looks like now. This is some of the pipes going in that tied in the New World Trade Center. Guess where those pipes are going? Hudson River. That's right. Use the resources you have. You know what other resources we're not using? We're not using drinking water energy exchange. They have over 1 billion gallons of water a day consumed in New York, and not a bit of it is used for its energy resources. We're working on that, but you got a lot of really scary people working in silos saying don't touch that. As a matter of fact, we were working on a study that was commissioned by NYSERDA, and we got a call from the governor's office that stop bugging the EPA over here, or whatever they're called, the DEC, because they're scared of you. They don't know what you're trying to do, so it'll happen. But there are a lot of silos we're still breaking down. This is another one we're doing in the Bronx called the Amalgamated Housing Cooperative. It's going to eventually tie in the Amalgamated Cooperative, DeWitt High School, Bronx School of Science, Lehman College, and Discovery High School. And this is one of the diagrams that NYSERDA requires us to do as we go along so that people can understand what we're doing. It ties in loops, it ties in the subway, it ties in wastewater energy, it ties in some more advanced district geothermal, which are something I'm going to cover in a little bit. Well, let me just put it this way real quick. What if I told you, because we did it in Boston, if you said, I need 700 tons and I have to go closed loop because there's competent rock and there's no water here, but I only have a flower bed, and you would say, no, I need a football field. Well, what if I told you now there's technology where you can use that flower bed and you can get 2 football fields worth of area at 600 feet down by radial boring? This is not only a good idea, it's happening. And there are 3 major companies, publicly traded now, that are doing the technology. So we'll talk, when we talk about it, you'll know what I'm getting to. This is a data center project we're doing in Wyoming that I'm going to talk about in a minute, just some cool pictures. What we call this is the water energy nexus, and I want everybody that leaves to think about it this way. Wherever we're moving water, we have the potential to be heating and cooling our buildings. Water movement, if it's moving anyway, is movement of energy. Water is the best carrier of energy we have. So it's the water. I won't read this to you. People think of hydropower when they think of water energy, but water energy really has to do with the carrying capability of water in the ground. These are 6 different ways we can use water in existing infrastructure in our buildings. Another great example is in Ontario, Canada. They get their fresh water out of Lake Ontario and they run it through a treatment plant. You can see this is a water treatment plant here on a little island. And then it goes in to provide drinking water to the city of Ontario. I want to say it was 2006. They finally, the N-Wave was the name of the company. They okayed an idea with N-Wave, which is an ESCO, an energy. Well, no, they were part of the government at that time of Ontario, and they put in this energy exchange plant, not different than the one you saw in the slide for Cornell. Now notice, they take the water out of Lake Ontario, treat it to drinking water standards, and then run it through exchangers, and then they have all the passive chilled water they need to do 273,000 tons of cooling in downtown Ontario. So obviously, they don't have a problem with using drinking water through heat exchangers. Who would? I mean, every time you go to a drinking fountain, a water cooler, or an ice machine, it's been through a refrigeration exchange of some sort. So it's like, we've been at geothermal 35 years. It just takes time, and you have to be patient, and it all comes to pass. I don't know why it takes so long. It's like waiting for us to adopt the metric system that they promised me. In 1960 in elementary school, we had to learn the metric system. They said by the time we got to college, it would all be metric. It's all going to be metric. And we're all going to be driving electric cars. That is starting to come to pass. So this is just a few of the prizes we've won in New York. This is a $3 million award for wastewater energy transfer at those two towers. And we're also going to heat and cool the building by adding loops after we do all the wastewater we can. This is just once again, they require these very simple depictions. This is one of the reports they require. How did you do this? Here you're using steam and an absorption chiller and some exchangers. Now here you're using a wastewater treatment system, and the heat recovery is going to DHW, and then for the rest of the heating and cooling you need for the building, we'll add the loops. So as it turns out, wastewater energy transfer on average does 40 to 60% of the entire heating load for a building. So wastewater energy transfer is probably the first thing you want to look at, because you don't need to drill any holes for that. And you're doing something good. You're using something that's running out of the building anyway. Another short example is in Chattanooga. The electric company hired us. We work a lot directly for power companies. And they said, how can we do an energy network in Chattanooga? So we laid it out. Oh my gosh, I thought I had more on this. We laid it out in several quadrants. I think I do have a hydronic on this coming up. I may have put it out of order. And gave them a great look at the loads. And what was it's close to 10,000 tons for this downtown district. And it's not that big of a big city. It's more of a smallish city. But it diversified down to 6,000 or 7,000 tons. I think I have that in a slide here. Now this is what I wanted to talk about. This is the new what's what. I remember the first time people started talking about the heat and electricity that is going to be used in data 10, 15, 20 years, I don't even remember. I was looking at my tower on my computer and going, yeah, I don't think it uses even 200 watts. What are you talking about? How can this ever be a problem? I had no idea what the AI and data age would bring. And so we are consultants for one of the largest developers of data centers. They have 7 1-gigawatt facilities under planning in the United States. And a gigawatt, just so you know, a megawatt is 262 tons or something like that. So a gigawatt is about 263,000 tons. So we have to do something with that heat, and that is the problem. And so this is an interesting story, because these cooling towers at the end of a data center, they're the most efficient way. They want to save energy because they're pumping out an extraordinary amount of heat, and all this active cooling is expensive, so they use cooling towers. Now these cooling towers average about 1 million gallons a day for each megawatt of data center capacity. And so a 1 gigawatt data center will go through 10 million gallons of fresh water a day. That's what happened here when Arizona went bat crap about this hyperscale center going in from Amazon or wherever it was. The headline's there in the link. And they said, no, you're not burning through 1 million gallons of water a day. That is our water. You can't do that in our backyard. So they started getting really creative, and in that case, they found some cool creative ideas, which I won't go into, that stopped them from using so much water. But one of them that's the biggest right now is these water parks. These huge lagoons and wave parks are going in. They've engaged us to put them in strategically near data centers and vice versa. The data centers, I have a charrette in Salt Lake City for 3 days next week, where these folks are coming together and trying to strategically place these. Now, think of Iceland in the hot springs. It's cold, right? But it's a really cool idea to swim in hot springs. That's what they're selling. And I hope I put it here. I didn't. I thought I put another slide in here. I toured one of these great big lagoons, not even 15 minutes from here. It's called Evermore, 7-acre lagoon, because they wanted to figure out how to heat it so they could get it all year swimming, because people just won't go in the water as much in the middle of the winter, even in Florida, because it's chilly. So we're working with them on some opportunities in Wisconsin now with the data center. So it just gives you an idea of just how crazy this is. Now this is that Chattanooga drawing. It just shows you all the sources and sinks for the geothermal on this side, and all of the different block loads, 9,900 tons, 8,800 tons, 3,600 tons, 4,800 tons. What it doesn't, it's a 27,000 ton total loop. It's diversified down to less than 10,000 tons in capacity. This software we use is amazing. These guys are on the floor. They're called HVAC Solutions. That's their website. We have to pay for our license too, but I'm so impressed with it. I always recommend it to people because we use it for laying out our system. So I'll stay there another second for anybody else and move on. I think I'm almost done. I want to talk a little bit about SVL and Corcam. We work with them like we work with McOtter in the upper Midwest. Corcam is highly invested into safe heat transfer fluids up throughout the country. So if you're putting in a geothermal system and you don't want to deal with the mess, they do a white glove service. In other words, that once the loop's in, they come and fill it and purge it and guarantee it. So that's pretty cool. And McOtter Energy, what I would like to do is just serenade one more time with this, because this is the last slide, and we don't have time for questions, but you can come up and talk to me afterwards while the thing's going. And that's my way of bowing out graciously, because I almost went over time. So here we go. Show's over. Enjoy yourself. And come up and talk to me or McOtter if you want. I'm trying to get that thing out of there so I can get this going. And here you'll get to see all that stuff in one cool place. Yes, right back where we started